This is Aisha Balmaceda, and the title of today's activity is about kinetics and chemical equilibrium. This is laboratory exercise number 002. The objective of this exercise is to make and record observations, measurements, and approximations. Interpret and evaluate experimental observations and data. General direction. Study the two experimental setups. Answer what is asked appropriately. Number 1. Identical pieces of brass were placed in two different boiling liquids for 12 hours. The graphs show how the mass of each piece of brass changed. Here, it shows on this graph is the brass in boiling acid solution, and graph B is the brass in boiling basic solution. On letter A, give one similarity in the change in mass of the brass in both liquids. Letter A, give one similarity in the change in mass of the brass in both liquids. Looking at the graph, both brass on boiling liquid change in mass by time. Letter A, give one similarity in the change in mass of the brass in both liquids. My answer is, by looking at the graph, both brass on boiling liquid change in mass by time. Letter B, describe two ways in which the loss of mass shown in graph A is different from that shown in graph B. As you can see on the graph A, the mass loss continues to increase during the 12-hour period given, and there is a high chance that it will increase or it will continue if the amount of acid is kept in constant amount as the time continues to run. As seen on the graph A, the mass loss continued to increase during the 12-hour period given, and there is a high chance that it will continue to rise if the amount of acid is kept in constant amount as the time continues to run. In graph B, the mass loss curved at 0.19 milligram sometime in 8 hours and maintained its mass loss amount per milligram until it reaches the time limit given of 12 hours. Letter C, list 3 different safety precautions that are needed in doing this investigation. For me, the first thing you need to do is to always wear goggles or face shield when working with acids and maintain a distance while performing any activity that includes acids. And 2, always be mindful when working with liquids to dilute acid on water instead of water diluting to acid. Otherwise, a chemical reaction will occur and can cause accidents. Number 3, use a heat-proof gloves that is long enough to cover half of your arm, and wear a laboratory gown or a coat to avoid skin contact with acid in case any splash or accident happen while performing the experiment. Number 2, the rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. When these chemicals react, they form a precipitate which makes the solution go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. 5 tests were done using the tools shown below, and this is it. Assuming that this is a 500 cubic centimeter conical flask, and this is your printed sheet, and this is your aqueous sodium thiosulfate, and you'll put 10 cubic centimeter of hydrochloric acid on it. On test 1, Using a graduated cylinder, 60 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask. The conical flask was placed on a printed sheet of paper, and 10 cubic centimeter of hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. And on this, I have recorded 45 seconds. On test 2, using a graduated cylinder, 50 cubic centimeter of aqueous sodium thiosulfate. On test 2, using a graduated cylinder, 50 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask, followed by 10 cubic centimeter of distilled water. The conical flask was placed on the printed sheet. 10 cubic centimeter of hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for printed words to disappear from view was measured as 55 seconds. And on test 3, test 2 was replicated using 45 cubic centimeter of aqueous sodium thiosulfate and 25 cubic centimeter of distilled water, and the time taken for the printed words to disappear from view was measured as 65 seconds. And on test 4, test 2 was replicated using 35 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water, and the time taken for this was 45 seconds. Test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium thiosulfate and 20 cubic centimeter of distilled water, and the time taken for this is 140 seconds. Okay, on page 5 of 7, letter A, use the stop clock diagrams to record the times in the table complete the table below. So this is the table that we need to complete. And so on test 1, volume the aqueous sodium thiosulfate per cubic centimeter is 60 cubic centimeters, and the volume of distilled water per cubic centimeter is okay. On page 5 of 7, A, use the stop clock diagrams to record the times in the table. Complete the table. On test 1, I have recorded the volume of aqueous sodium thiosulfate per square meter. Okay, so on page 5 of 7, use the stop clock diagrams to record the times in the table. Complete the table. On test 1, volume of aqueous sodium thiosulfate per cubic centimeter is 60 cubic centimeter, with a volume of distilled water of 0, and time for printed words to disappear is 45 seconds. On test 2, 50 cubic centimeter volume of aqueous sodium thiosulfate with volume of distilled water of 10 cubic centimeter, with time for printed words to disappear of 55 seconds. On test 3, volume of aqueous sodium thiosulfate per cubic centimeter is 45 cubic centimeter, with volume of distilled water of 25 cubic centimeter, and time for printed words to disappear is 1 minute and 6 seconds, or 66 seconds in equivalent. On test 4, volume of aqueous sodium thiosulfate per cubic centimeter is 35 cubic centimeter, with volume of distilled water of 15 cubic centimeter, and time for printed words to disappear is 1 minute and 18 seconds, or 78 seconds in equivalent. On test 5, I have recorded 10 cubic centimeter of volume of aqueous sodium thiosulfate with a volume of distilled water of 20 cubic centimeter, and the time for printed words to disappear is 2 minutes and 20 seconds, or 140 seconds in equivalent. On this diagram shows the 5 tests that has been made, with this as a test 1, test 2, 3, 4, and 5. So on this graph, you'll see that on test 1, where I have recorded 60 cubic square meter with of aqueous sodium thiosulfate, with the time for printed words to disappear of 45 seconds. Same goes with test 2. I have recorded for 50 cubic centimeter with 55 seconds time for printed words to disappear, and test 3 with 45 cubic centimeter and have recorded a time of 66 seconds, and test 4 with 35 cubic centimeter and with a time of 78 seconds. And on test 5, you'll see that I have recorded 10 cubic centimeter with 140 seconds time for printed words to disappear. There. On letter C from your graph, infer the time for the printed words to disappear if test 2 was repeated using 50 cubic centimeter of aqueous sodium thiosulfate and 15 cubic centimeter of distilled water. Show your solution and how you come up with an answer. Well, for me, the 15 cubic centimeter of sodium thiosulfate was projected upwards until inserted the graph pointed towards left. Okay, so on letter C from your graph, infer the time for the printed words to disappear if test 2 was repeated using 15 square meter of aqueous sodium thiosulfate and 15 square meter of distilled water. Show your solution and how you come up with an answer. On letter C, my answer, where we used the 15 square meter of aqueous sodium sulfate directing upwards. Well, here, as you can see from the graph, as shown here, where we use the 15 square centimeter of aqueous sodium thiosulfate and directing upwards with our graph projecting from right to left and ending at 120 seconds printed words disappear. And then on letter D, in which test was the rate of reaction greatest? Explain why the rate of reaction was greatest in this test. Well, on letter D, in which test was the rate of reaction greatest? Explain why the rate of reaction was greatest in this test. My answer is on letter D, compared from the test 2 to 5, the amount of aqueous sodium thiosulfate is higher because it was not diluted in or with water that caused it to react faster. And that's the end of our laboratory exercise number 2 of kinetics and chemical equilibrium.